evolved. Apart from the advancements in the diesel and gasoline engine and such things, when we talk about being an automotive engineer, nothing very interesting happened until we put the ECU in the car, right? So 1981 was the time when GM actually put the first ECU in the cars. And with that, I mean, all of a sudden we had a small computer sitting on your car, right? And in this computer device, you could actually write hundreds of thousands of lines of code to actually, control your different, controllers that you have in the car, right? You can plant some logics in your automobile in order to have some high level functionalities in the car. So 1981 is where the first issue came. And then basically, if you look at today's picture, we get a high level glimpse that I mean, bringing the ECU on board opened up the possibilities of many more control logics or embedded controllers in the car that we see these days. So that is where today, if you look at your car, it is, a mini computer that you are driving on wheels. It has so many, effective systems. When you talk about emergency braking, if you talk about, your airbags popping up, now we are seeing four-wheel drives also, quite commonly, and many other, features that you see in the car that we take for granted today, right? So what has actually led to the, advancement from 1981 just having ECU to the, technologies that we are seeing in the cars today? So, that, I mean, this is the first digital transformation that I'm talking about, by the way, where we see embedded controllers everywhere in the car system. And, the technologies or the, foundation behind these technologies were mainly the model-based designs. And, in this embedded controls journey, the evolvement of this embedded controllers, data analytics also had to play, some small amount of role in terms of engine calibration, where you can, based on the different environmental conditions, you can basically tweak your engine parameters a little bit in order to meet the emission norms, in order to meet the, exhaust gas temperature regulations, and many other things, basically, right? So that is where, this was the first digital transformation. Now, the second digital transformation that, started happening on the modern cars that we have these days, it started, from BMW assist system, where in 1998 BMW actually had a network of, first network of connected cars, right? And soon following this, Mercedes-Benz also, started prototyping their algorithms on how they can use some visual inspection techniques, some computer vision techniques, basically, to actually come up with some lane following system or lane departure system. But if you look at the, snapshot from that time frame, also the lane detection technique was using some rectangular lane, detections, right? So that is how the journey actually started in deep learning in the automotive sector as well. And if you look at today, now these days we are seeing much more advanced cars. Suddenly, your car has become interactive. You can talk to your cars, basically. So some luxury cars, if you just pop them in, I mean, pop into these cars, you can all of a sudden talk to the infotainment system, just like, having an Amazon Alexa at home, right? So you can talk to your car, ask them, to play a certain radio channel, ask them, maybe if I'm on a long trip, is it going to rain in another 15-20 minutes? So the car infotainment system follows your command and gives you a nice set of responses. But now, especially today, what we are seeing that, with the connected car technologies moving, I mean, taking a step forward, right? We are seeing that certain technologies like predictive maintenance and also integrated vehicle health management, these are starting to evolve now. All right. So what I mean by that is, with predictive maintenance sort of technologies, all of a sudden, you can monitor multiple subcomponents in the automobiles, right? And you can constantly monitor, the health of these components and predict the failures ahead of time. So you know how many number of kilometers you can run more on your automobile before you need to bring them into service. So it is not about a scheduled maintenance, nowadays, right? So what I mean by these transformations, over here is all of a sudden bringing data science based, applications into the automobiles. this has become an another service that the automotive manufacturers are offering to their customers. When you are actually buying a car these days, you get an option that do you want this feature also to come along with your car? Do you want an app from us also which can continuously monitor the health of the car and lets how your different subcomponents are doing, whether your car tire pressure is actually holding out, and if your tire grip is actually holding out based on your driving profile and all these things. So a lot of possibilities are actually opening up, and very soon we are going to see a very big transformation in the industry, right? So before I move forward, I will also, have want to have your attention. I think Vijay will also paste Microsoft form in the chat, so that you can actually, towards the end of the session, when you have gone through the content, or if you can look at the Google Forms now, also you can fill them up. Let us know, about certain questions that we have in the form. So I would request Vijay to kindly save that, please. And also, moving forward, from this, what I emphasized on, again, the model-based design and the data analytics-based workflows are leading to a very heavy, transition in the automotive industry when it comes to intelligent systems, right? And this was the second digital transformation that I spoke about, where we see artificial intelligence in almost every subsystems that we have on the automobile. Now that I have shown you a high level overview of where the automotive industry is actually heading towards, let me start diving deeper into some of the technical stuff, right? So what it takes basically when we want to implement the AI based technologies in the automotive sector these days, right? So this is a small survey that Gartner did in 2020, very recently actually, and everybody knows about Gartner, right? So they wanted to understand what are the top bottlenecks for different companies when they want to implement a data analytics based application into the cars, right? So I will give you a high level overview of what this survey tells us. It tells us about the different challenges that the different industry, the different companies in the automotive industry are actually facing these days. So let's say that if the company has also devised these AI applications, have tested them out, one challenge is how do they integrate this with the existing infrastructure, the existing technology that you have in the car. You may have developed a nice algorithm, but can you deploy it onto the ECUs in the car, right? Then the second level of complexity comes around the data quality, right? So are you recording the data correctly? Is the data giving you enough insights, right? And then the third thing is, the lack of skills when it comes to data science, and the domain expertise, right? So what different companies are seeing these days, either they have the data scientists, but not the right set of skills when it comes to understanding the machine itself, right? On the other hand, if they have the domain experts, they don't have the basic data science skills that is needed for developing a smart AI algorithm, right? So that is where MathWorks focus, in the past 2 or 3 decades has always been to design products which will enable our domain experts to do their best job. And the same story actually holds out true even in the field of data science. So whatever we have been doing is mostly based on how we can enable the domain experts, using some UI based applications. They don't need to dive deeper into what line of code that we need to write, and by using their domain expertise can they develop smart systems, like we want to see on the machine, right? So with that thought, I will start, showing you some of the user stories. And at this point, I will also request Vijay to share, the complete slide deck in the chat box with the audience, so that, while I'm going through the different user stories, they will also have a look at the slides on their end, right? I have, multiple user stories to also show you today. So the first one from the automotive sector is, the BMW actually solving oversteering problem using data science techniques, through our solutions, right? Through MathWorks solutions. Um, And then basically the second one is from the industrial automation and machinery sector, where Atlas Copco actually has built a dashboard completely in Matlab, where it monitors 120,000 industrial compressors across the globe for Atlas Copco. It is a real-time dashboard running 24/7, completely built in Matlab. Okay. The third one is from the aviation sector, where Airbus has been using MathWorks deep learning workflows to use computer vision and visual quality inspection to find out the defects on their aircrafts, right? And then the fourth one is from Vitesco, and Vitesco is basically an electrification company, and lot of electrification technologies that you see on your cars today are being actually developed by Vitesco, and Vitesco has been using deep reinforcement learning workflows in a in a closed loop control systems, right? So although I am showing multiple user stories, over the screen to you, what I'm going to do, I will dive deeper into how BMW has actually solved oversteering issue using our MathWorks workflows in data science in their cars. And then the second one I'll be taking on is Vitesco using deep reinforcement learning in the powertrain control systems, right? And while I go through their story, right, I won't have the complete models that they built, for confidentiality reasons, obviously, to show you. But I'll talk at a high level, what different types of features or toolboxes they have used from MathWorks, basically, in order to solve these kind of problems that they had, right? Um, So before I dive deeper into these user stories, right, I will talk about how an AI workflow looks at a high level, right? So when we talk about developing, okay, so I'm reading some chat messages that my voice is breaking. Vijay, can you confirm if you can hear me properly?
Yeah, Piyush, it's okay for me, but for others, most of the people, is it okay or it is at very few?
Okay, sir,
What
it's
do you-
going well, sir.
Okay, okay, fine.
All right, yeah,
Okay,
that's
please put it in chat in case if there may be some internet connections that you ends
yeah,
will try to.
that's why I'm not sharing my video so that the bandwidth is should be okay. Okay, so
Yeah,
I'll
go
go
ahead,
back to
Piyush.
the script then. Okay, so the AI workflow at a high level basically consists of these four buckets, where the first step is basically you have the data from your machine, or you may have the data from the different component designs that you are simulating in an environment. It could be a Simulink environment also that you are actually having the component designs, or it could be any numerical software that you also would have around your machine, right? So how do you gather data? Is the first step. How do you gather data and import it in Matlab, right? Then comes the second step on how we use this data and feed it into the different AI modeling techniques that we have, the different types of AI models that we have, right? And how do you, after training these AI models, how do you actually, test the accuracy of these AI models on the new data that the model hasn't seen so far, right? Then after having a good, validation check of this AI model on the new data that you have fed it to this model, you want to, before deploying this model in the real product, you want to carry out some more system validation and verification by developing a prototype and just testing it out on one or two machines. Do a lot of validation and verification that whatever I have designed as a data science product is actually holding true in the field, and then you take it to deployment on the either on the embedded hardware, or in case your analytics wants to in case your analytics is more like a dashboard that you want to build, you can deploy it either onto the cloud, you can deploy it onto your organization intranet. You have the abilities to deploy it as a standalone executable, right, to the end user. So many forms of deployment workflows are being supported by Matlab, right? So but let me go one level deeper, and here I will talk about what you do in each of these buckets, right? And first and foremost thing is to tell you that while I'm talking about these four buckets, each of these buckets have lot of mini workflows embedded in them. For example, if I talk about data preparation, so what are the challenges when we talk about just handling the data, right? So your data could be big in size. You may have the data which is not going to fit into the memory in the first place. How do you handle those challenges? On the other hand, let's say if you're dealing with a signal data, right? There could be a lot of noise present in the data. How do you smoothen the data in that case? How do you remove different outliers from the data, right? If your data has some missing information corresponding to different variables that is there in the data set, how do you handle all of that? Based on the domain knowledge, how do you come up with some new features, or new set of variables in the data set? So for example, if I mean when I'm talking about feature generation, feature engineering, what I essentially mean by that, if some of you are actually new to data science and also learning data science, let me tell you that a good data scientist or a good domain expert who understands the machine would look out to model some of the new features or new variables in the data set which your which you don't have off the shelf, right? So what I mean by that is, for example, let's say that you have an moving object, right? You are actually employing some force on that object continuously, and what you are recording is the velocity at which the object is moving and what is the force employed on it. Only these two features you have in the data set. Can you use differentiation of the velocity instantaneously in time to come up with acceleration of that object, right? So something like that, right? And so you did not have acceleration in the data set, first of all, but you have, based on simple physics understanding, you have developed a new feature in the data set. So those human insights help you actually build very good intelligence systems, right? And then the third challenge that that we see different customers facing is when they deal with the real world data set, right? Mostly when you design any particular component and deploy it into the field, you will not experience failure straight away. It takes certain amount of time for different components to fail. And when you don't have the failures in the field data that you are collecting, right, then how can you generate some failure data so that you can build a predictive maintenance sort of application, let's say, for example, right, where you need to train these AI models for failure modes, different failure modes, so that these models can actually predict failures ahead of time for you, for example. So that is where this model based design workflows help you build your complete system architecture, let's say in Simulink. And then you can correlate your model with respect to the nominal data that you are gathering from the field, and then start injecting failure and generating the synthetic data for different failure modes. So those are some of the challenges or mini workflows in data preparation itself, right? Now let's say you have done a lot of data preprocessing, data preparation, all these things. Your data is ready to be fed into the AI model. That is where in the second bucket, there are multiple machine learning and deep learning models available these days, right? How do you choose which model is the best fitted model for you, right? That is the first challenge. People who are actually new to the data science field, they actually struggle with identifying which model do I need to pick, right? And I don't know the hands-on code for all the models that we have. How do I get started and develop something very quickly? And that is where I'm going to also show you in the later slides how we have been helping our customers adapt to machine learning based workflows very quickly, right? Then, another challenge in AI modeling is if you are dealing with big data sets, right? Then your model training also takes a lot of time, and that is where MathWorks also supports hardware accelerated training. What I mean by that, if you have much better compute resources available with you, let's say you have access to a GPU or multi GPUs for that matter, or having access to a good cluster for that matter, right? MathWorks supports all of that actually through MATLAB, right? Then we have support for interoperability as well. So let's say if you are actually working on an open source platform like R and Python, MathWorks has libraries to import your Python-based models into MATLAB, and vice versa. You can export your MATLAB models into a Python framework as well. So that is what interoperability is, and I'm going to talk about it in upcoming slides as well. Now, the third bucket is mostly around system design, where we do a lot of system validation and verification. After you have actually built a nice AI or machine learning model, you actually want to validate it onto your real system before actually deploying it directly onto the production right. So that is where we deploy our code. They do a lot of system verification and validation on some prototype, and then in the fourth bucket we finally deploy it on either onto the embedded devices, or like I mentioned, if your deployment workflow is more of a dashboard or a smart application that you have built for the end user, you can choose to deploy it either onto the cloud or onto the local desktop, or on your organization's intranet as well. So that is what I mean we have in the deployment bucket as well, right? So with that, let me start with the BMW user story, right? And what you can see on the screen, I'm not going to read through each and everything, but at a high level, BMW had this oversteering issue on their cars. And oversteering basically is a phenomena where on some corners and turns, if you are actually having some high velocity and you are oversteering your vehicle, right? That is where the rear tires start to lose out grip. And in certain cases like this, you will see the smoke also coming out of the rear tires if your velocity is much higher, right? But even in our cars, if we are not maintaining a decent speed and are oversteering basically on the corners and all, slowly over a period of time your car tires start to lose out the grip. That at a high level is the oversteering challenge for you, right? So what BMW did was they wanted to solve this using data analytics workflow. And BMW has access to very good skilled drivers who actually drive their race cars as well. So they did a lot of testing on their car, had the driver understand, I mean have the driver tell them at what points in time during the test the car was going through oversteering. And also a real professional driver who drives race cars and all, he would have a very good understanding of where you are oversteering your car and all. So they collected, this data using a driver's insight as well, and then later, used MATLAB products, right, to actually develop a small proof of concept in just 3 weeks' time. So if you look at what they had to say about their experience on MathWorks workflows, you can see that in just 3 weeks' time, they were able to design a prototype and which they deployed on the ECU. And this particular prototype was able to detect oversteering with an accuracy of 98%, which is amazing result, right? So the first proof of concept in just 3 weeks time. And they also mentioned that they have very little experience with machine learning, little to none actually, right? So that is what I'm going to talk about, how they could get started and do this kind of thing in just 3 weeks time. Now, like I said, I don't have the complete model and these things to show you from BMW how they did, but I'll be showing you workflows in MathWorks products, which basically helps you do this kind of operations in a quick time, enabling domain experts to achieve good results when it comes to data science based workflows, right? Again, I mean, when I'm talking about the workflow, this is how training an AI model actually looks like. You take a historical data, you pre-process the data, generate a lot of features, and do some low-level analysis. Feed the model into feed the data, the pre-processed data into a model. It could be a supervised or unsupervised model and all. And then you actually train the model on the training data, right? So using this historical data, the model has been trained to in order to predict something for you. Now, in the testing phase, basically you bring in the new data where the model's responsibility is to take this new data and give you a prediction. How do you do that? All this pre-processing step that you had, you do on the new data as well, and then you use the model that you have trained, right? Feed this pre-processed new data to the model, and it will give out the prediction for you. That is what to a beginner, a machine learning based workflow would look like, right? Now, after your model has been developed, you can choose to deploy it, either on embedded devices or on different platforms, like I spoke, previously, right? So also at a very high level, I mean, data analytics, is obviously a time bound thing, right? So if you have less time available, you want to achieve results quickly. That is where you can follow, some UI based, applications from MathWorks, where basically in quick time, like I spoke about the BMW story, you can use different, apps from Matlab basically to actually process your data, and multiple features that Matlab and Simlink has to offer. You can use that in order to make some quick progress if you have lesser time available. But at the same time, if you have more time available with you when you are actually developing these systems, let's say you have given yourself 1 or 2 year time frame to really design a smart system which will be pretty robust, right? That is where domain experts also have the option of actually diving deeper into the physics, use model based design based workflows, right? From Simlink, design this whole plant model in Simlink, also test them out in time, generate some synthetic data as well if needed, and then basically in a long time they can actually build some robust product. So that is where, what step you need to take based on the volume of the data that you have, or based on the time that you have available, right? So I really like this graph, which gives you a very high level perspective of things on how to actually start out on your machine learning application, right? Now let's talk about, what are the challenges in the data preparation step. I mentioned about, the three things on the left hand side: data cleaning and human insight, and also generating synthetic data, right? But let me also tell you, some of the complaints that we actually hear from different customers who are getting started in this field. So in the data preparation step, you know the general feedback from the community is, I have files available in multiple formats. It could be a text file, it could be a CSV file, images, videos, multiple other things, right? We have files available in different databases. Our files are too huge in size, right? I have some signals basically recorded in the data, right? All these things. So basically, what I want to tell you is MathWorks supports, or I mean, multiple different types of file formats, whether your data is actually stored in a text file, CSV file, images, videos. Like you can see, you can process signals also using our signal processing toolbox. It has the ability to read data, bringing data from multiple types of databases, right? And another thing that I want to show you on the similar lines is MathWorks actually has a very unique data type called data store. So what data store does is, it is just a pointer to where your data is sitting. When you actually define the data stores in Matlab, give this data stores the exact location of where your files are actually sitting. It could be in the cloud, it could be on the cluster, it could be on your desktop, doesn't matter, right? What data stores also do is, it just goes through one sample file, understand what are the different variables present in the data set. It also gives you an option before you bring in the out of memory data into Matlab. Before you start bringing the data into Matlab, it gives you an option to scan through the data, understand what all features you want to retain in the data. So let's say my data files are having 25 different variables, 25 different sensor parameters in the data, right? I may not want to use all of them for my analysis. Some of them may not be required, right? So I don't want to bring those data points into my workspace in Matlab, right? So it gives you an option to drop these features. It gives you an option to read only certain lines of data, and it gives you an option also to have some customized importable function written on top of the data store, which will also do some data pre-processing steps even before bringing the data into MathWorks platform. That is Matlab workspace, right? So multiple, data processing operations you can do before bringing the data into Matlab. And there is also something called as tall arrays in Matlab, which also has the ability to handle big data really well. I think someone is not on mute. So it will be good if you can go on mute if you're not talking, please. Thank you. All right. So what you can see also on the screen that MathWorks actually supports a lot of different types of data stores. We have the capability to have data stores designed around images, audio files, and signals as well. And also on the normal text data and all these things, we have multiple different types of data stores. Right now, let me dive one step deeper and show you some of the workflows. When I kept on mentioning about the UI based workflows enabling the domain experts to do their best work without knowing uh, the um, the underlying code behind some of the operations, right? So that is where I'm going to show you something about live tasks in MATLAB. So before I actually go through this video, what I want to show you is this is how your MATLAB platform actually looks like. MATLAB client actually looks like. Where this particular tab is the live editor tab. You have a script that you can write where you have the option to write a lot of rich text formatting as well. And then in these gray areas, basically you can write your code. What it helps is it helps another user who has not developed the code to understand really what the developer has tried to do if he has given good explanations about what he is trying to do in this particular step. Also on the right hand side, you see these three buttons. Basically what it does is you have the option to completely hide your code and also use this script to generate a report so that you can present it to someone else and they don't want to see your messy code or long lines of code. They don't want to go through that. Just your explanation and the outputs of the code they can see in terms of the different graphs that you may be generating and many other things, right? So it gives you all these options, these three buttons. But really what I wanted to show you this was over here you can see the task button over here that we also call as live tasks. So in this data pre-processing step, although this particular script has multiple different data pre-processing steps, I'm not going to go through all of them. Just going through one or two of them, is going to give you a high-level overview of what I'm talking about. So in the first step, I'm actually going to show you how do we handle clean missing data by using the UI-based technique. So what you will see over here is in the data pre-processing library in the live tasks, you will see that I have multiple different commands available with me, multiple different buttons available at my disposal. And then in data pre-processing step there is another library on handling tables and timetables, right, where you can perform multiple operations, like if you want to join two different tables, if you want to resample your timetable frequency, if you want to stack or unstack your timetable, and many other operations, right? So in this particular example I'm going to use clean missing data, this first one, right? And what you will see as soon as I click on this, right, it imports a UI, library in my script, and then I need to select, what is my data variable, right? And then multiple other options it gives you that if your data is missing, you just want to eliminate those rows or you want to actually fill the missing information by using some interpolation techniques, and multiple interpolation techniques are also available with you. So as soon as you select something, it actually shows you a graph of, where all you had the missing data and how it has interpolated the data and all. And if you really want to dive deeper into the code also and see what is the underlying code, so that is where you have the option to enable that as well. So later if you want to actually generalize this on some, in some other workflows as well, you can do that by using this code, right? Similarly, for cleaning the outlier again, you see in the data that we have some huge spikes in the data set. So how I want to actually clean those outliers? Again, I'm going to the live task, selecting the particular button. It imports this UI library, and then you select your data that you want to import. You select some detection algorithm. Like over here, I'm using a moving median technique with some threshold value. So what it does is basically you can see over here that it actually generates two horizontal gray lines, which are the threshold reason for me. Anything outside of it will be considered as outliers, and you have the provision to increase or decrease the width of this gray region basically. and whatever data is outside of it, I have chosen in this drop down menu to replace these values with a linear interpolation, right? So that is what it is doing, right? So a domain expert would want to actually look at the data and perform these operations that he understands from his expertise, right? That my data is not looking clean, right? But he doesn't need to go to the code and figure out, what I need to write, in the command field, and what all commands I need to give, right? So that is where this UI based workflows really help you out. And then in this particular video, I have some similar things on, smoothing the data and also resampling the timetable. But I think this gave you a high level perspective of, how to do data pre-processing using UI-based workflows. Now, the second thing I wanted to show you was on the feature extraction, right? So I spoke about, how to generate new features in the data set previously, right? So that is where this diagnostic feature designer app. So I mean, let me pause over here at the beginning of the video. What you will see is in Matlab apps gallery pertaining to multiple domains that we handle, right? Using Matlab, whether it is control systems, whether it is signal processing, image processing, and computer vision, and multiple others. You can see that this scroll bar is having multiple other domains to go through. But in the signal processing domain, you have this diagnostic feature designer app available with you, which you can actually use to create some time dependent and frequency dependent features from the data. So what I'm doing over here is I'm actually importing my data from a triplex pump into my workflow, and this data is actually having multiple fault codes also labeled. So this pump has different types of faults, and I have data pertaining to different types of faults. Sorry, I think, yeah. So I am importing that particular data set over here. So the motor current, motor speed, everything is actually imported, right? And I mean, if you look at the data over here, what you will see on the right hand side, I have the data coming in multiple colors representing the different fault codes, right? And on this data, on this time series data, I want to select only one particular region. You can do that. You can snap to only that particular region, extract the features out of that region itself. And then you have options of selecting your time domain related features, your frequency domain related features. And then in time domain related features, pertaining to your data, you can select I mean, all these small checkboxes around. If you want to generate the mean of the data, if you want to generate standard deviation, kurtosis, skewness, multiple other things basically. So in a matter of seconds, you will have all the time dependent features available with you in a feature table, right? And then basically moving forward, similar thing you can also do with the frequency domain. Let's say you want to understand what are the prominent frequencies present in my data. Let's say if you're handling a vibration data set, right? Something like that. And what is the amplitude of the different frequencies? You can do all of it. Now, once you have the feature table, right? Then basically what this toolbox also helps you do is it helps you rank these features based on one way ANOVA test, right? Or it could be the t-test that you want to do, right? So it helps you rank these features, with respect to how important they are in understanding the different types of faults that I had in the data set. So some of the features are not that important. So you may want to choose, let's say, only top 3, 4, or 5 features from the data. You can do that. I mean, select these. And also, the good thing with all these toolboxes in MATLAB or all these apps in MATLAB is whatever operation you are doing in this UI-based workflows, right? You can export this in form of the code, or you can export all these features also directly into your workspace. So that is what I'm doing over here. If you want to look at the code, which has been underlying, I mean the code that has been used under the hood to go through all this operation, you can again export that code. And then maybe if you want to generalize this particular operation on another data set, you can just execute this code by feeding another data set basically to the function wrapper, right? So that is what was about that diagnostic feature designer application that we have in MATLAB. Then this third one is corresponding to the synthetic data generation that I spoke about, where you, if you have, good amount of time for your application, you can actually model of a physics-based system in Simulink and Simscape libraries, and then basically you can simulate your machine performance, validate your machine performance with respect to your field operation. And then, as you can see over here, you can actually create multiple features for understanding, what kind of fault your data is actually representing, right? So you can see, as my simulation is being carried out, it understands whether I had a blocked inlet or a seal leakage or something like that, right? So that is how you actually generate a synthetic data, by creating some digital twins in Simscape and Simulink, right? So with that, I think I have given you a high-level overview of how MathWorks workflows can help you in data preparation step, right? So also another thing is when you are actually developing a deep learning based workflow, right, where you have data in the form of images, videos, and let's say so one of the dark truth of deep learning is that you need a very good amount of label data at your disposal. What I mean by that is, let's say if you have an image, something like this, right? You want to have labels around what objects in the image are cars, what objects in the image are actually road, pathways, mountains, hills, sky, and many other things, right? So that is where, multiple labeler apps also we have, in MATLAB platform, basically around labeling your images, videos, signals, and multiple other things, right? And then, one thing I would like to also point out is we have a lot of underlying algorithms. Let's say if you are dealing with video labeling, right? So something like this, you have a recorded video of you driving a car, where you see these many number of cars ahead of you, right? So in this particular video, you just label, one particular frame. Under this application that you see on the screen, and then as you play on the video, automatic detection of these cars also happens. So all the frames gets labeled. It also points out in which frames, your data has not been labeled correctly, and then you go back and correct those labels, right? So that's where, labeling your data sets in deep learning based workflows also becomes very, very easy, right? So now let me talk about, the second bucket, that is on AI modeling, right? So when we talk about machine learning in specific, right, we know that, there are a lot of, algorithms out there, right? Whether you talk about supervised learning in classification or regression, we have support vector machines, we have, random forest, and simple things like linear regression, polynomial regression, and many other things, right? K-means clustering, PCA, right? So when we are talking about unsupervised learning, right? So all of these, models are being supported by MathWorks as well, right? In MATLAB, right? When it comes to deep learning, right, we know that there are some pre-built or pre-trained, models available in public, where large companies like Google and all have done a lot of work, using their high compute resources to train deep, networks, which consists of, 150 layers of hidden layers or something like that, right? So some of the public models are also available, in MATLAB, like AlexNet, VGG, ResNet 50, and YOLO V2, V3, these kind of models, right? So those are also available in MATLAB platform. And then basically, you have multiple reference examples also to get you started on deep learning based workflows, either on semantic segmentation, which is more about, the image that I showed you over here. This is the semantic segmentation example from the automotive domain, right? So all of these are also available, in MathWorks, to help you get started quickly in this space. Now let me also show you that when I spoke about, not being a data analyst, right, being a domain expert, how do I pick the right set of model, right? That is where I'm going to show you something on AutoML, right? Where again we have, apps around classification learner and regression learner. These two apps are the machine learning apps which help you, select the right classification algorithm or right regression algorithm to train your model onto, right? So let me show you the classification learner, for example, right? And here again from this apps gallery, I'm actually selecting the classification learner app. I am going to import, the pre-processed data from my workspace, my Matlab workspace, into this app. And as soon as you select the data table, you will see that it automatically understands which one is your response variable. If not, you have, this drop down to select the correct response variable, and all other, variables present in your data set, it highlights as the, independent features. All right. So then on the right hand side, you have the different validation techniques that you can follow, either cross validation or holdout validation. And then basically you start the session, right? Once you start the session, it just shows you a plot of the two variables that you have in the data set. This is not relevant, since both are most likely the independent variables, but you can see how your data actually looks like. Now, I mean, basically, if you click on this drop down, you see that we have multiple different types of algorithms supported over here, right? And these are the classification models, the classification machine learning models available with you, right? But like I mentioned, I'm not the domain expert. I mean, I'm not the data scientist. I'm a domain expert. I just quickly want to understand which model will actually fit my, time bill, right? So that is where, I can select all the models basically, from this. I can enable, parallel computing by selecting on this use parallel button over here. What it does is it allows my machine to actually use more number of, cores if needed, right? So for example, my current laptop is a quad core machine, or let's say if you have access to better compute like, a cluster or a GPU, you can just set that up in the preferences segment in MATLAB. And then just by click of this button, it will enable you to access those, high compute resources as well. So where the model training becomes much, much faster, right? Then I clicked on training. You can see that, so many number of models are actually in the queue for training, and some of it are being trained automatically, right? So here you will see that SVM support vector machines is actually giving me the highest accuracy. So the highest accuracy model is automatically picked. And then, in the post processing, you see multiple different options available with you at the top. This is the confusion matrix when we deal with classification workflows. And then you can see which, classes are not being, worked out well through model training. You have the option of mentioning the misclassification cost. So let's say that my label one, my class one has not been labeled correctly, right? Then you can actually increase your misclassification cost, and now you see that, my class prediction specifically to class one has actually is actually showing me 90% accuracy now. So all this fine tuning of these different models, as well as, the confusion matrix based results, can be done in this workflow, right? Then you have the option, let's say in support vector machine, to actually use advanced techniques like Bayesian optimization and all. You can enable that, experiment a little bit, if you have some data science background also a little bit. Otherwise, so something like misclassification cost, PCA also you can enable over here. All these things you can do. And then, like I mentioned, in the diagnostic feature designer app over here as well, if you have trained a model, you just want to export this trained model into your workspace, you can do that by click of a button. If you want to export the whole underlying code behind training this model, that is also possible by just click of a button, right? So that is what AutoML is for you. It automatically trains so many number of, models and gives you the best possible model. Similarly, in the deep learning based workflow, right? Again, from this apps gallery, we have this deep network. Sorry, I played the first video itself. Let me play the second one. Yeah, so when we are talking about deep learning, we are essentially talking about the neural networks basically, right? So again, in the deep learning based workflow, right, from the apps gallery, you can also launch this deep network designer, or you can just write deep network designer, execute that code. It pops up this particular app for you. Now here, what you would see over here is when this app actually launches, right? What you will see over here is we have so many pre-trained networks which are out there in public. So MathWorks also supports all of these networks. in native MATLAB code, that you can actually use these pre-trained networks and just perform just actually train the last few layers of these networks if required for your application, or you can start out completely from scratch, build a blank network, right? That is what I'm going to show over here, right? And building a deep learning network is very easy using this app-based workflow in MATLAB, right? So you can just import your input layer, some convolutional layers, and these ReLU layers. You can copy and paste them multiple times. So these operations you can do. Then if your output is, let's say, your uh, regression based workflow, if you are executing, right? So a regression output is towards the end, and that is where you can also mention your image size and all over here in the input layer. And likewise in every other layer you can manually mention it also. And then you have some analyze button at the top. So before you start training this particular network, it does the dimensionality check on your network, so that the output of every layer, if it is passing correctly to the next layer or not. If is the next layer configured to receive the output of the previous layer? Are the dimensions checking out good, right? So that is what it does, and helps you get started quickly on building a deep learning network, right? And then if you want to just,
Piyush, there is
yeah,
one
yeah,
question in the chat
please go ahead.
from Raj. It's around training so many models sequentially will significantly increase the computational time.
Correct.
So, is there any other simpler way to get a classifier model for my data or application?
Yeah, so that is where, if you understand what you have actually trained, what your underlying data set is, right? If you understand the data set well, we recommend that you start out with some simple models like support vector machines alone. Instead of selecting all the models that I showed, you start out with one particular group of models like support vector machines. You try out a simple regression model from the drop down. So I showed that in the drop down over here you have multiple models available. It is up to you what you want to select actually. So if I want to select only decision trees for example over here, so all trees I can actually import, or I can select the ones that I require. See what is the output of that, right? Otherwise, training all the models is going to take time for you, but it depends on how big your data set is. For example, in this particular example that I'm showing, my data set is not that big. My 4 core machine can easily take this and finish this training job in 10 minutes flat, something like that, right? So then trying out all the models works out good. If your data set is really big, then you need to actually do a little bit of research on what model I need to train, pertaining to my data set. And like I mentioned, if you have access to better compute resources like GPU or a multi-core machine also, for example, right? Let's say instead of quad core, you have 16 cores in your machine, right? You can enable parallel computing to accelerate your training. I hope that helps you. That answers your question. All right. So going back to the deep learning based workflow, I was mentioning how easy it is to actually design these deep learning networks, in MATLAB using Deep Network Designer. Now, one thing is, in deep learning based workflows, you have to tune the hyperparameters in order to increase the accuracy of the model, right? So that is where, we have support for something called as experiment manager in MATLAB. Right, so let me go to that particular thing. So yeah, so this experiment manager, basically you import your deep learning network in over here. You can mention what would be the hyperparameters that you would like to tune going forward, right? As you go through training the model and finding out which hyperparameters will actually give me the highest accuracy, right? So you can mention all of that in this particular application, right? And also mention what is your evaluation metric, your cost metric basically. And here, for example, I am actually running through 4 different hyperparameter tuning workflows, right? And as you can see, obviously depending on the compute resource that you have, actually I've used multiple hyperparameter sets over here, but it allows you to set up your experiment on hyperparameter tuning, and then you can choose the model which has the highest accuracy on the test set for you, right? So suddenly, doing experiments with a deep network or a deep learning network, right, becomes much more easy for you if you understand, what all hyperparameters tuning will help you gain much more accuracy on the network, right? So that is what I wanted to show you in AI modeling workflow. Yeah. I mean, in terms of our offerings through different apps, right? Now let me talk about, how MATLAB can help you with, I think there is one more slide over here. Yeah, so how it can help you with interoperability, right? So MATLAB also supports the Onyx, platform basically. So let's say you have models developed in TensorFlow or PyTorch, right? If it is of Onyx standard, right, you can import that piece of code in MATLAB directly, and similarly, MATLAB models can also be exported onto the, in the Onyx platform basically, and then you can embed those models either in PyTorch or TensorFlow. At the same time, we also have support for Keras and Cafe models to be directly imported into MATLAB, right? And also on hardware accelerated training, like I mentioned, if you have, I kept on mentioning if you have better compute resources, but if you're working on Azure platform or AWS platform where you get access to multi-core machines, multi-GPU machines, a very wide array of clusters that you can choose from. If you are going to be willing to pay some money in order to access these resources, MathWorks do support workflows around Azure based and AWS based hardware accelerated model training and all, right? You can create Docker images as well, right? So that's where MathWorks, like I mentioned, our effort has been to enable the domain experts quickly go through their machine learning workflow. So we are doing all the things that are possible in order to integrate these different cloud platforms also with MathWorks in order to reduce your training time drastically, right? So
Piyush, one
yeah,
more question.
please go
One
ahead.
more question in the chat.
Mhm.
Think it's from Charusila. If there is a class imbalance in the data, will the accuracy of the confusion matrix will work there? Are there overfitting in deep learning networks? If it's not clear, you can ask Charusila to explain also.
Yeah, so I'm not very clear about what it actually means, but class imbalance, let's say, if you're talking about the prediction, right, then it is definitely around how you tune your hyperparameters. Also in the machine learning models, like I showed, if there is a class imbalance, in terms of certain classes not being predicted well by the model, right? So I think she's typing something. I can't see the chat directly. Uh,
Charusala, you can also unmute yourself and ask the questions.
Yeah, actually, I was saying like suppose if we have two type of classes there, like suppose I have 1,000 products with me, and in 99 999 those products are fine, and there's a fault only in one of them. Then my accuracy definitely becomes above 99%. So, but my main goal is to find out which is the faulty product out of those.
okay, so let's say in the input data itself, if you have very heavy data on one particular class, and the other class doesn't have a lot of data, right? So one thing that I would like to point out is in MATLAB also, right, we have different techniques to augment your data when we are talking about deep learning. So let's say if you are having an image, so how deep learning based model trainings also work is, let's say if I have only 500 images pertaining to some application that I'm building, but that is not good enough data set for me. What I can do is I can do a lot of image augmentation. I can increase, decrease the brightness on the images. I can rotate the images in different ways. Still, your classification should come out good. Doesn't matter how your image has been augmented. I can create flipped images and things like that. So using these techniques, right, we also have apps around, image augmentation, video augmentation, and all these things. It helps you expand your data set from just, let's say, 500 images to so many more. so that you have the proper, class balance in the input data itself. And then, hyperparameter optimization actually helps you even more, right?
Yeah,
So
sure. Actually, I was mainly asking which accuracy matrix shall we use in such scenarios.
yeah, so accuracy metrics, so what I can do, Charusila, is there is a lot of, accuracy metrics that we can actually use. What I'll do is maybe after this session, I can send you some links to go through, right? So if you can fill out the Google form also that, I mean, not the Google, but the Microsoft form, we have a lot of information about the different accuracy matrices that we actually can follow depending on the application. So I can, send you some of the video links to also go through, or the documentation links that we have, right?
Okay, yeah, thank you.
Yeah. Um, all right. So, I mean, since I went through data preparation and data modeling, right? I wanted to show you a user story from Mitsui Chemicals on how they used interoperability, with Matlab. So basically, they had their entire model code developed in Python, right, using TensorFlow and KDAS, and they wanted to deploy their algorithm using Matlab, platform, right? That is where they actually brought their Python code into MATLAB using Onyx standard code, and then basically designed the whole dashboard and the deployment part of it. I mean, deploying a dashboard on the cloud is what they went after. But I mean, this is a very good, user story on how interoperability between Python and MATLAB can actually help you go places, right? Um, so with that user story, moving forward, let's talk about, the third bucket, which is simulation and testing. And like I mentioned, if you have trained your model well, checked its accuracy on the test data set, next thing you want to do is actually validate this even more on by actually deploying a prototype on hardware, right? In when the real world data is actually being fed to the model, right? So here I am showing you a user story from Voyage. Voyage is basically a taxi company where they are actually manufacturing a level 3, autonomous vehicle in this particular user story. And in just less than 3 months, they were able to do this validation and testing with very good accuracy, on their prototype, right? So you can see that they have a good network, of the entire powertrain, right? And different control segments in there, right? So, and also on the top of the car, you can see that there are a couple of cameras installed which records the live video feed, in front of the car. How they process through, the video feed for multiple subsystems and help you detect, the different, obstacles in front of you, or also helps you classify which ones are the pedestrians or the, lanes on the street and things like that, right? So let me show you a quick workflow around that. So far I have been talking about MATLAB, but Simlink product from MathWorks also, offers some machine learning and deep learning based, blocks in Simlink to be imported. For example, here I am actually importing two different. So let me play this video. So here I'm actually importing two different, deep learning based, blocks in here. One is on the lane detection and the other one is on the obstacle detection or the object detection, right? So these two blocks are consisting of the trained models that we have, right? Now on the left hand side is the input video that I have from the cameras which are installed on the car. On the right hand side is the output or processed, video that you'll be seeing. So as I play this, you will see that the raw video is being recorded, and at the same time, it is detecting two things for you. The first thing is the different obstacles in front of you. Then you start seeing these lines also, which are detecting the lanes for you. So that is where you do this kind of system validation and verification before actually deploying your models directly onto the product hardware, right? You build a prototype, test it out using Simlink or Simscape models for a long period of time, and then deploy it onto the product. Um, we have another video to show you basically how we can I mean, do this system verification and validation. So here, what I'm showing you is basically this orange one is a PLC machine that we have, and then behind this is a speed goat machine, which mimics the real hardware, behavior. So in case you don't have, let's say, heavy, equipment with you like a car engine, but this speed goat machine will help you mimic the behavior of, real engine, for example, when it comes to, recording different types of data. Then, I mean, the way it is all set up in this particular video is somebody has also, built a dashboard using Matlab. You can see that this is a Matlab app designer that they have used. They have built this particular dashboard where when they actually click on this start, the application, it starts the speed goat machine, which starts feeding you the raw data as it would come from the car engine for any nominal operation or for different types of operations that will also have the different types of faults labeled onto the data, right? So all this you can do in order to simulate the behavior of any particular real asset that you have. And then you can see on this particular screen, all the raw data feed is actually coming, and then your application can actually detect if there are different types of faults on your machine and things like that, right? So I mean, now about the fourth bucket, right? At a very high level, I will show you this particular
Piyush, one more
structure.
question.
Yeah, go ahead.
I think from the standard question, what is advantages to use MATLAB over Python or any other open source languages?
Yeah, so advantages, I would mention that you have to look at the end-to-end picture, when you are working on any machine learning algorithm. Python and open source frameworks are really good, when it comes to actually training your AI model or testing your AI model, right? But at the same time, you also have to look at some other challenges, like I mentioned about big data handling. MathWorks has unique set of data types, like I mentioned, data stores, tall arrays in specific, which I did not talk about in detail, but you can go through our documentation. These two things are really capable of handling big data really well. Another thing is after you have trained your models, right? You want to deploy it onto some framework, right? Either it is a dashboard that you would like to build and all, right? So that is where this particular slide is. I will talk about it in detail, but you have to think about after you have trained your machine learning model, what you want to do with it. Your model training and all is not good enough if you are actually thinking about the bigger picture, that is deploying an application which will serve the end user really well, right? That is another thing. And then for beginners who don't want to dive so much deep into what code will actually help me and what types of algorithms we have, that is where in this app based workflows that I showed, just by clicking on a drop down menu, it shows what all machine learning algorithms you can import. Like I showed, all the machine learning model training can actually happen parallelly. So all these features is what in my personal experience also, so I come from using an R background before joining MathWorks. But I mean, after using MATLAB, I've seen that I have to spend less time on model training and focus more on how would I want my end product to look like, right? And how do I address some of the real pains which are around data pre-processing, signal processing for that matter, right? So that is where, with MathWorks, our code has been very strong in how does it handle different matrices and math functions, basically, right? So that is what I have to say about, but it is very, subjective, between comparing open source and, MathWorks products. But that, I mean, this is also from my personal experience as well as, looking at the bigger picture. All right. Um, All right. So on the deployment aspect, right? So this flowchart is basically a high-level overview of what are the different products that we have to offer, when it comes to deploying your application. So really the question is, where do you want to deploy your application? If it is on the coder, I mean, if it is on the embedded hardware directly, right? Let's say you want to deploy your algorithm onto an ECU device, right? That is where, MATLAB coder products can help you convert your MATLAB code into a native hardware code like a C code or SDL code. and that is again, when we are comparing open source versus MATLAB, we have products for converting your code into a C code, by just using some UI interface, right? And you don't need to again figure out how do I write the same lines of code into C and C++ so that I can deploy onto my native hardware, right? So think about all these things when you're comparing open source. Then the second thing is, if you're actually building an application like an app and or a dashboard that you want to host on the cloud, that is where our compiler products are there. Either you can create a simple app using MATLAB app designer like the one I just showed you in the previous video, right? So these apps can be converted into a standalone executable. You can create an Excel add-in, multiple other things. And this stand-alone executable, when you share with the end user doesn't need to install, MATLAB onto their machine. They don't need to have a MATLAB license for it. In other words, or in simple words, it's a royalty-free distribution for you, right? At the same time, we have deployment options using MATLAB web app server as well, where if you want to actually host this application within your organization, where multiple people are actually available on the same intranet, you just want to share the URL with the end user. They don't need to again install anything on their machine, right? That's where MATLAB web app server, comes into play. Then MATLAB production server helps you set up a cloud interface and talk to your data lying in the cloud. And also, if you have a third-party dashboard like Microsoft Power BI or Spotfire, things like that, that is where MATLAB production server can host your analytical algorithm and talk to your raw data and fetch the processed outcome of your algorithm to these dashboards that you have on the cloud. So I think, Vijay, is there any more question, before I move forward?
So there is one question around what is the role of automobile engineering in AI field? How a automotive engineer can excel his career in AI trend?
Correct. So that is very interesting question, and that is where some of the things that I talked about. You saw me showing some deep learning based, applications like ADAS, right? Automated driver assistance system, right? Where this lane detection and also object detection was there. So these are some of the applications, that are actually evolving, and pretty soon you will see that these are generalized, things in the new automobiles. So that is on the deep learning workflow. There are multiple other applications that different companies are actually trying out. And being an automotive engineer, what I will tell is, if you are an automotive engineer, you understand these machines, you understand the car engines and the two-wheeler engines, right? You understand how your technical sensor parameters would look like. You understand how a normal system would behave, right? So applications like anomaly detection, right, and estimating failures ahead in time, something like a predictive maintenance, right, are some of the trends that different companies are actually looking for these days. And we are actually also working with multiple companies in these areas. And from my experience, what I can tell you is this field is having a lot of promise in the next 5-10 years. We are going to see a lot on predictive maintenance, integrated vehicle health management sort of applications, right? And that is where a domain expertise is certainly needed in order to quantify the different types of failures and also predict them well in advance. So that is where it is pretty interesting on how you look at both the worlds, the fielded data, and also if you have the design background, you would have seen how a nominal data will also look like. Are they correlating with each other, things like that, right? So I hope that gives you a good perspective of how you can use our automotive experience in something like a predictive maintenance application.
So there is one more question from Raj. A common problem faced in automatic code generation MATLAB to C is that there still needs to be manual manipulation of the MATLAB code.
Yeah,
That
so
we may have to define a variable size beforehand, which is not the case in C++. So a compiled and operational MATLAB code cannot readily used for automatic. Is there a solution to this?
yeah, so Vijay, would you want to take that, or I can take
Yeah,
that as well?
you can go ahead. Go ahead.
Yeah, so my take on that is, yeah, I mean, obviously, if your code is actually, I mean, not a very simple code, right? I mean, I'm talking in a layman language so that everyone can relate to this. So definitely, some bit of tweaking will be needed in order to actually create some portions of the code manually, right? But at a very high level, at least 80-85% of your long lines of code can be converted very easily using MATLAB Coder, right, into C, C++. Obviously, it depends on, what all toolboxes you have used from MATLAB. Not every toolbox support is there currently, but the development team is also working on addressing some of the common challenges that our community has been facing. But as of today, a good percentage of your code can be converted very easily into C, C++. But let's say you have, written down some really complex code around, let's say, signal processing and all, right? It needs to be simplified in simple terms, basically, which your coder products can actually understand and convert in C, C++.
So Raj, also there might be we don't know which version you are using, and there's a lot of developments that happen with respect to the code
Yeah.
generation support. So in case you have some specific problem, you can, I mean, our email addresses are also there, and you can drop a email. We'll be happy to discuss and see how this can be supported and what are the current supported and what are some things in development also. We can share it with you. We can get into a detailed discussion on that. And Piyush, one more question is there from Charu is on does also MATLAB deployment could be integrated with Azure or AWS cloud service?
Yeah, certainly. So that is where, the MATLAB production server I was highlighting, and I have personally worked on, deploying, my analytical algorithm on AWS, and my colleagues, also have worked on Azure deployment. So basically, AWS and Azure gives you access to a virtual machine where you can host your MATLAB production server based, analytical algorithm. Your data can be read through S3 bucket or Azure Blob storage. But when we are talking about MATLAB production server, you need to also think about, what is your end dashboard, right? So ultimately, all this analytics you want to read in some dashboard like Microsoft Power BI, or Spotfire, right? So it, I mean, Azure, AWS are the platforms where you can host your, MATLAB analytics, and then the end dashboard has to read all of this, whatever this analytics is actually feeding you as the output, right? I hope that answers this question. All right. So in the interest of time, I will actually move forward, with the presentation. So coming back to the BMW user story, I mean, this is a technical newsletter that is also available on our website from BMW on the same story that they mentioned that, they used MATLAB Coder also in this oversteering problem. And basically, one interesting thing is they tested this particular, algorithm on a different vehicle, right? So they tested it out on, BMW 5 Series instead of M4 Series on which the data was recorded initially, right? So instead of doing that, they were able to see 95% accuracy, which is a great testimonial on how a beginner can start, building simple machine learning applications, using our workflows. Um, and then after this story, let me also show you this MATLAB coder video. And this is a very quick video. Basically, you can launch the MATLAB coder again from the apps gallery. You can mention in what source code you want to actually generate your code. And here I'm selecting my application, and my end result is C code. So that actually shows, how you can actually convert your MATLAB, code into a native hardware code. Similar to this, we also support SDL code generation and many others. Okay. Um, so what we touched upon, in today's presentation is, the different challenges that we have around data preparation, AI modeling, system design and validation, and deployment of your analytics. So a couple of highlights from, from the talk so far is MATLAB enables the domain experts to do data science. I showed you so many different types of apps that we have. And when I repeatedly mention domain experts, it goes without saying that you won't have a very strong background in data science. Some high level understanding and processes you would understand, but the underlying thing about being a domain expert is, let's say if you don't have a very strong analytical background. So that is where Mathworks products help you do things very much quickly. And then on the deployment aspect, like I mentioned, MATLAB Analytics can sit anywhere or can run anywhere. I talked about deploying it either onto the embedded devices or generating standalone executables or hosting your application either on the intranet or on the cloud, things like that, right? So far I had to talk about machine learning and deep learning. Now the other user story I talked about Vitesco, right? So that is on reinforcement learning, and this is a little more advanced, concept. But I'll try to keep this, very simple and give you a high-level overview. I know that many people would not have worked in the reinforcement learning sort of application, and this is a new domain that people are actually, or engineers are actually exploring today, and it is pretty fascinating. I will show you a couple of videos also around that. But machine learning in general, comprises of unsupervised learning, where it is more about not having the labeled data. You just look at how do you cluster the data. So something like anomaly detection examples you can think of. The second thing is supervised learning, where you have the labeled data, where you can do some classification and regression sort of problems. And then the third thing so far I also discussed about deep learning, where your file structure is more in the form of either time series data, or is it an image, or is it a video. So how do you use deep learning based workflows, especially neural networks, is where this particular domain is. And then the reinforcement learning basically comes into play when we are dealing with a dynamic data set at a high level, right? So in the automotive industry, I will tell you how it actually comes into play, and that is where this user story from Vitesco is a really, really good example. They had also given us, given a talk at MATLAB Expo, last year. There is a very good video around how they explain their problem around powertrain controller case study. It's a 20 minutes long video. It is very fascinating to watch. Okay, so basically the real challenge in automotive domain is that your environment is also changing pretty fast. Let's say that you are actually on a long trip, right? And you are going to a hill station. I'm just taking an example, right? So your altitude levels are changing very fast. Your oxygen levels in the air are also changing. At the same time, let's say somewhere down the road it starts raining, right? Then the moisture also comes into the air that your engine starts sucking, right? So a lot of changes you experience very rapidly on the automotive engines, let's say for example, right? So that is what I mean by having a dynamic data set where your input parameters are evolving continuously over a period of time, right? And in this particular example that Vitesco was actually working on this particular case study, they were actually working on this powertrain controller model, which is a closed loop model, and they were monitoring the exhaust gas temperature, which needs to be under a certified limit, right? As your environment variables are changing. So that is where, so I am not an automotive, engineer, so I will not go, I will not be able to go deep into what these blocks actually mean, but what they say also in the talk is, understanding how to model this exhaust gas model and also this state feedback control, block over here is where they actually employed reinforcement learning, right? As this was the portion which was actually changing, pretty rapidly, right, depending on the environment. And we also know that the emission norms these days are becoming stringent a lot, right? In 2023, there is going to be a much stringent, emission norms. So how do they comply with those norms with changing, environmental conditions, right? So that is where they also have a testimony around using the reinforcement learning toolbox in Simlink environment, which enable them to do the prototype really fast, right, using our RL toolbox in Simlink, right? So this slide I will show you on the reinforcement learning basics basically. So at a high level, it consists of an agent block and an environment block. And the agent block I mean, it can encompass the whole model completely, and it has the ability to take some actions on the model. And since the agent block is actually, talking to the environment sees, what action you have taken on the, I mean, the different blocks that you have in your model, and it gives you certain reward. So one thing very fascinating when you actually start out in the data science field is you will understand that, these deep learning models and reinforcement learning models specifically have been built on human intuition. So how we work in our daily life is what reinforcement learning you can relate to. One very good example that I would like to quote is, let's say you want to actually start on reducing your weight loss, for example, right? What you know from knowledge is, okay, my physique is also not looking good. Let's say, for example, I want to start eating out healthy. Day one, when you do that, right, the environment around you sees that, okay, you are actually eating healthy food for one day. It rewards you by a weight loss of 100 gram, let's say, for example, on day one, right? Then you start doing that more often, right? You do it for 1 week, 2 week, the environment rewards you with 2 kgs, 3 kgs of weight loss, right? Then you decide, okay, what can I do more on my body? You start running, you start joining gym, you start doing this daily course on, exercises, yoga, what all, right? So the environment learns that, okay, you are doing all these productive things, right, which is good for your system, and then it, rewards you in getting back in shape, right? In the similar terms, let's say environment is changing. You, when you were going out for run in normal days, all of a sudden it starts raining, and you do that action of going for a run in the morning in the open, right? Then, you catch some cold, right? So the environment actually feeds you, I mean, it actually rewards you with a cold, cough, sneeze, and things like that, right? So we take some action, and the environment actually, I mean, gives you a reward. Then basically, if the reward is negative from an environment, in this, weight loss example that I'm talking about, let's say you catch a cold, then basically you need to change your course of action, right? You want to eat some I mean, drink some herbal tea to get, into shape, back again, and things like that, right? So that is how the reinforcement learning model also, works, right? So as the environment is actually changing, like I mentioned, on a long trip, if it starts raining, there is moisture, you need to adapt to the changing environment. You need to decide how to actually mix your fuel and air mixture so that my exhaust gas temperature is still within the limits, right? I think it is a good, correlation with a real world example that I quoted, which would help you understand how reinforcement learning is actually doing. But at the heart, I mean, under the hood, reinforcement learning is more likely an optimization problem that we are dealing with, right? So I mean, this is a very good video to just show you how reinforcement learning blocks can be actually imported in Simlink environment, where you have, multiple things around the control system, and then basically in this reinforcement learning block, you can pretty quickly bring it in Simlink and feed it, the observation reward, things like, I mean, that I spoke about, and same reinforcement learning, can be also executed in the Matlab environment by actually writing some lines of code, right? So both the options are there. Either you want to design your system in Simulink or in Matlab, both the things can be done. Now let me show you reinforcement learning model, how it starts to learn, and this is pretty fascinating, right? So when you start training your reinforcement learning model, this is an example of a robot trying to walk a straight line, right? And this video is definitely a speed up, but what you will understand, it is still trying to make its first step. And the different controllers that it has, the different knobs it has, right? If those are not tuned rightly, right, then it just keeps on falling down. But towards the end of the video, you will see that after episode number 10 or something, right, this robot starts to take its first step, right? And that is how the reinforcement learning model actually starts to, I mean, that is how the reinforcement learning model is being trained, right? So now at the same time, like I mentioned in other workflows, if you have access to better compute resources, you can enable multiple cores to do this training. And that is where, this crosstalk between the agent and the environment can happen in parallel, and then it accelerates your training, right? Now in the second video, I'll pause this first one. In the second video, you will see the end product where this robot, after, so many number of episodes, it learns how to walk a straight line, right? So that is where, this agent that is being built on top of the controllers, that is on the robot, it takes certain actions on those controller settings basically, and then, the robot starts to learn to take its step in a gradual manner, and finally it understands how to walk a straight line. So I will not. Okay, so I'll skip this particular slide. So, this one is again from Vitesco, just showing, how they created this reinforcement learning based, block in Simulink, and what their plant model actually looked like, which enabled them in fast prototyping their reinforcement learning agents in Simulink, and build a prototype pretty quickly. So I would suggest you, I know that for a larger set of audience, this will be a very new topic, but I'll suggest you to go through this talk that Vitesco has given. It is there on our website. You can go through that. And then, one pretty good thing about, the different toolbox or different features that we have in MATLAB is our documentation is actually pretty good around everything that we do. So any new person who starts out in the environment like this for reinforcement learning I'm showing, we have contents around the different examples with proper code and proper Simulink models that can help you get started in this particular space. Similarly, when I talked about deep learning, when I talked about machine learning, we have many different examples that you can use with proper code, in our documentation page, which helps you get started, get yourself familiarized with how do we handle different types of data, and many other things. So I would highly encourage you to go through our documentation, when you are actually doing any sort of research also, let's say on any application that you also are building, right? So, and then on top of that, I want to show that, while at the beginning, I talked about 4 different user stories from different industries. We have worked with many different, types of customers from different industries, whether it is from industrial automation, where you can see cell using deep learning based workflows to classify different types of meters and, machines in their factories. And there are good examples from the medical sector. There is good example on the stock charts, basically, from the finance sector over here. This voice example that I showed you. What I want to emphasize on is MathWorks is actually not just providing you a software to work on, right? What we also do is we also offer our engineering support to you. 1 second. Yeah. So I will just come up with this particular ending slide where I want to mention that we offer, our engineering support also to you in case you are just getting started out, in this particular domain of data science, right? We also do hand holding, we also do consulting projects with you, so that you can get started in this space quickly, and then once you have developed a good understanding of how to build this sort of applications, then you are on your own. So those sort of services also we offer. Another thing is MathWorks also offers, the training courses basically. So let's say you are getting started on the platform, you don't know what all is there, and then our training team can come and help you get trained on how to use any particular type of module in MATLAB, right? That is where I would highly encourage you to go through our training courses as well. So there are some self-paced training courses. For example, this machine learning on ramp and deep learning on ramps are also free for you to actually go through. These two are just 2 hours of content for you to go through, and the deep learning one also is 2 hours, and the machine learning ones is also 2 hours. Then there are some paid trainings as well that one can actually take in, depending on, what type of problem they are actually dealing with, what type of application they are building, right? So something like MATLAB fundamentals also, is also available on our website to go through. And then depending on the sector, there are multiple trainings that we offer as well, right? So with that, I actually come towards the end of the presentation. If there are any questions I can take. Otherwise, this is my email ID. You can reach out to me personally, on this mail if you have any queries. And you can approach me on LinkedIn as well. And I have given my LinkedIn URL to you. You can approach me over here. Any questions that are there I can take?
So I think there are no further questions.
Right. So Vijay, I think you would have pasted the Microsoft form as well
Yes,
in the
it is
chat.
already there, and we saw some responses there.
Awesome. Awesome.
Please unmute and talk. Yeah, give the rights.
Excuse me, sir.
Yes, yes. Please go ahead.
Sir, how is India ready for this kind of domains like the ADAS systems? Like these are worked in like Germans, and their technologies are so advanced that their vehicles, the systems that the ADAS cannot be used in India because of so much. Uh, so much of disturbance in the traffic or so much complexity in the situations. So how is India or the how the situation of India is ready for this kind of systems or this kind of things?
All right. So let me answer that. By giving you two perspectives of how data science is helping automotive industry in India specifically, right? So first is ADAS based workflows, right? So ADAS, like you said, in India, you are seeing heavy traffic and all these things, right? So ADAS based workflow is not only about, object detection and the lane detection. It is also about identifying the distance between your vehicle, let's say, and the next vehicle that you are recognizing, right? So ADAS based workflow also helps you in enabling something like an emergency braking system, right? Let's say you are driving on a highway, for example, and you see some animal actually crossing the road, right? It detects that. It lets the machine figure out, how much is the distance, and then your emergency braking system can actually come into play. Same thing in the traffic scenarios as well. You see a lesser traffic in the road, and then all of a sudden, ahead of you in few hundred meters, there is a traffic jam, and then it enables you to do emergency braking, right? So this is one example on ADAS that I've quoted, but another suite of applications that we are seeing different industries in India approaching is fleet management. By that I mean that they are. I'm hearing an echo. If you're not talking, please go on mute. That would be good. All right. So what I mean by that is these companies like Honda, Suzuki and Ford, you can see that different fleet analytics, applications. In coordination with MathWorks support, we have helped our customers develop, right? And in India, different, automotive industries that we are talking to. Different automotive companies that we are talking to. I will not, give you the names of which companies I'm referring over here for confidentiality purposes, but they are heavily working towards this IVHM sort of application, integrated vehicle health management. They have a network of connected cars. They are recording data, whether it is about recording the health of the battery, whether it is about recording the engine parameters. They want to figure out how to optimize the drivability feel. They want to recognize how to predict the age of the battery, how to build an RUL model of the battery, the remaining useful model of the battery, how many number of cycles it can last more, depending upon how quickly you charge, discharge them. We have applications in the electric vehicles as well, right? So I hope it gives you that a perspective that Indian automotive companies are also working towards applying data to their machines in the field.
Maybe just to add to Piyush, see, this technology, whatever was covered, I think it's more, as we have seen, all systems are becoming smart and it is becoming an integral part of any kind of a workflows. So whether it is for India, right now we are just looking at a fully autonomous, but take the things other, it's more like smart manufacturing, industry 4.0, predictive maintenance,
Yeah.
your analysis, whatever you are trying to do, fleet analysis, like when Piyush covered how you can provide it as a useful service. So a lot of applications are there, and it is applicable to Indian automotive. And also India, we have the talent pool, which will be servicing all this global. We are a large global in-house centers also. So it's kind of an integral part of it. It's not uh, no more. It's not like a luxury, nice to have. It's a must-have technology, and I think it is cuts across all applications, whether you're a mechanical engineer, electrical engineer. It's so that's what Piyush was again and again saying, like a domain engineers, right? So that's one thing.
So one last question I want to ask.
Yes, Sudeep.
Sir, first of all, thank you for to ACE India for providing such a wonderful session, and we got to know about many things. Sir, I am currently pursuing in a third year mechanical department, and I learned Python. I have a pretty well knowledge about hybrid electric vehicles,
Mhm.
and I'm pretty keen about this automotive electronics domain, like many systems which is used like the traction control system or the many different things which are the electronics domain, like the ADAS, like rollover mitigation and several things like that. So if I want to get into this domain, what are the things I have to gain, what are the things I have to learn to get relevant in this industry, and so that I can work in this domain? If you can guide me in that thing, so that's all I wanted.
Okay. Vijay, would you want to take that?
Yeah, I have put Sudeep. That's a good question. I have put some links to the student competitions, racing launch. That can be an initial way to start. There are a lot of useful materials, and then you have some applications related to automotive reference examples available in our website. You can go through it, and as Piyush said, you have our email address also. Any specific things you get started, I can look at it actually.
Hello, Vijay. Maybe I can answer that. So I am Parmesh from Continental. Sudhir, I can actually answer two of your questions here. So first, being with respect to the ADAS point of view. We work closely with the uh, we are actually closely working with the Indian OEMs in order to tune in the performance for the with respect to the connected cars or be it with respect to the ADAS systems. So that is a parallel activity which is going on. Very soon, I think by 2025, we should see at least the initial norms being sent out from the automotive Ministry of Transport for having these safety systems. And next, with respect to your question, so you are pursuing mechanical engineering, and with respect to, so there are various aspects, like the vehicle dynamics and your ADAS systems. So in order to pursue on that, okay, since I don't know so how exposed you are to the electronics here, because at least as far as I'm concerned, you have to at least understand the mechatronics point of view. So I'm sure you have the mechatronics. As Vijay also mentioned that there are certain competitions which is organized, many competitions by SAE and some of the universities also. Other ways is maybe you could start with some courses with respect to ADAS understanding. So it doesn't limit you since you are a mechanical engineer, right? As that you should only pursue this. So there are other areas in vehicle testing. So where you have this dynamics, where uh, uh, a graduate from mechanical would understand more into the vehicle dynamics aspects. Okay, so the testing aspects of the mechanical, so be it the stability control, or be it the NVH level of the vehicles, or be it the battery management systems. So all these respect to the body to weight ratio, how the new cars, the electric vehicles are designed with respect to the weight aspects. So all these areas which will help you to go for this. So it is a wide topic for you, and you can get to choose whichever you want to pursue. So that's it from my side. Thank you.
Thanks, Mr. Purvis. That was a very good reply coming from the industry expert. All right, so
So yeah, I know we are behind lunch. So thanks a lot, Piyush, first for taking your time out on Saturday to deliver the session, and thanks everyone for again taking your time on a weekend and attending the sessions and making the sessions more interactive. In case if you still have questions, you can go and share it. I mean, put your questions or reach out through the email ID. We'll be happy to take it because each one will have a different questions and it will come from different perspectives. Today, our idea was more to give awareness, and I hope you got all the awareness about the AI in automotive. So with that, let's end the session. Thanks a lot, everyone.
thank you everyone for taking out time on a Saturday to come and listen to us. Thank you.
Thanks, Piyush.
Thank you, sir. Thank you very much, sir.
Thank you all.
Have a nice day, everyone. Thank you.
Thank you. Thanks, guys.